So this is the chain rule. All right. So before we go into chain rule, I'm going to go back and talk about the composite functions. All right. So you learned about composite functions in pre-calculus, right? So somewhat very important because the composite functions allow you to do something called the inverse functions as well, because you need, in order to show the inverse, you need to do some two functions composed with one another. But that's for pre-calculus. For this calculus 1 material, we talk about composite functions because we want to take the derivative of this type of functions. Let's remind you what the composite function is. So compositions of two functions, f of x and g of x is, so the notation is f composed with g of x. This is equal to f of g of x. All right. First, given the input, you can use g for a map. So this is the input here. And in terms of g of x is the output. Now g of x become an input for f, right? So f of g of x. I could say this is input and this is output. Right, so functions within function. Right, so that's the idea behind composite functions. Start with one input, you calculate it for the output, and this output become a new input for the function f. And I usually say that g of x is the inside function or inner functions. And f is the outside function or outer function. All right. So that's the composite function for you. The next thing that we want to do is you want to find the derivative of this function. And therefore you need to know the chain rule. For the chain rule, let's say that if g is differentiable at x and f is differentiable at g of x, then the composite function capital F equal to f composed with g and defined by f of g of x is differentiable at x and f prime is given. So this is the formula. So f prime is equal to the derivative of f of g of x prime. So derivative of the composite function is equal to, so let me use a different color here. So f of g of x. Right, so f is the outer function and g is the inner functions. So I have f prime of g of x times g prime of x. Right, so I want to note here, this is, you take the derivative of the outside functions and you multiply with derivative of the inside functions. So that's basically chain rule. Different notations here. In Leibniz notations, right? Leibniz notations is dy dx, right? If y is equal to f of u and u is equal to g of x, both differentiable functions, then dy dx is equal to dy du times du dx. Let me use a different color here. And so this is dy du times du dx. For dy du is the derivative of the outside functions. And du dx is the derivative of the inside functions. Once again, for the chain rule, it's the derivative of composite functions. When you take the derivative, it's equal to the derivative of the outside functions multiplied with the derivative of the inside function. Okay, so let's take a look at some example. So find f prime if f is equal to square root of x squared plus 1. So this is the composite functions because you have x squared plus 1 is inside the square root function, right? So you say that u, which is identified as the, you can say that that is the inside part of the functions, right? So x squared plus 1 and capital F of u is equal to u to the 1/2 or square root of u, right? So let me be careful here. This is square root of u or u to the 1/2. You want to have the derivative of this composite functions, right? So f prime is equal to I could say that is equal to df dx, right? Just try to follow the formula right here. So this should give me df du times du dx. Df du is the derivative of this u to the 1/2. What is the derivative of u to the 1/2? So this is equal to u to the 1/2 prime times the derivative of the inside part, the inside functions, right? X squared plus 1. So x squared plus 1 prime. Right. So u to the 1/2 is equal to 1/2 times u to the 1/2 minus 1 times the derivative of x squared plus 1, which is 2x, right? Because the derivative of x squared is equal to 2x, and the derivative of 1 is equal to 0. Well, you simplify this and you get x times u to the negative 1/2. But what is u equal to? U is equal to x squared plus 1 right here. So substitute that back into the result. You get x times x squared plus 1 to the negative 1/2. Just keep in mind that derivative of composite functions or the chain rule is going to be the derivative of the outside function multiplied with the derivative of the inside function. And that's it. So let's take a look at another example here. Differentiate y equal to psi of x squared. So first of all, identify what is the inside function and what is the outside functions. You let u equal to x squared for the inside functions. Y is equal to psi of u, right? Because u is equal to x squared. So the derivative of this function psi of x squared, which is the composite function, is equal to the derivative of outside functions, psi of u prime, times derivative of x squared, which is the inside function. This one should give you psi of u is equal to cosine of u. time derivative of x squared is going to be 2x. Okay. And u is equal to x squared, so you substitute that back into the result, and you get cosine of x squared times 2x. So one more example, slightly different from this particular example. So I want you to differentiate y equal to psi of x altogether square. Right. So the inside function is no longer x squared. It's actually the entire side of x. Right. So the derivative of that is, and the outside function is the square function. Right. So let me be careful here. And the inside part is u equal to sine of x. And the outside part is y equal to u square. So derivative of this is u square prime times sine of x prime. Right, because I just want to follow the formula dy du times du dx. Right, so dy du is equal to 2u, and du dx is equal to cosine of x. And u is equal to sine of x, so this should give me 2 times sine of x times cosine of x. So I'm going to give you another example. Differentiate y equal to x cubed minus 1 to the 100. So the inside part is x cubed minus 1. So you let u equal to x cubed minus 1. And the outside part is the power 100. Right? So you have y equal to u to the 100. The derivative dy dx is equal to dy du times du dx. Right, once again, dy du is the derivative of the outside part, and the du dx is derivative of the inside part. So dy du is equal to u to the 100 prime times du dx, which is x cubed minus 1 prime. So dy du is 100 times u to the 99 times x cubed minus 1 prime, which is 3x squared. And u is equal to x cubed minus 1. So you get 100 times x cubed minus 1 to the 99 times 3x squared. Can you differentiate this exponential functions? Y equal to e to the sine of x. All right. So for exponential function like written like this, it's hard to spot which is the inside function, which one is the outside functions. On the calculator, right? So if you have a calculator or if you have a phone and open the calculator app, there's a good chance that the exponential function is written in this word exp to indicate exponential functions. So anytime you see exponential function, you can rewrite this way so that you can easily identify what is the inside function and what is the outside function. So for e to the sine of x, you have exp of sine of x. So that indicate that the inside part is sine of x and the outside part is actually the exponential function. Right? So you let u equal to sine of x, and y is equal to exp of u, or e to the u. And we still follow the formula dy dx is equal to dy du times du dx. Right. So let me move this down here a little bit. So dy du is equal to what? So dy du is equal to e to the u, right? So derivative of e to the u is still e to the u, right? And the derivative of sine of x is going to be cosine of x, right? So you know dy du, which is e to the u times du dx, which is cosine of x. But u is equal to sine of x, so you get e to the sine of x times cosine of x. So for this example, I want you to find the derivative f prime of x if f of x is equal to 1 over q root of x squared plus x plus 1. Right. For this, you can rewrite this functions as a power functions. It's easier to do with. Right. So first, try to turn the radical into a power. So you have x squared plus x plus 1 to the positive 1/3. Right. And you bring this into the numerator, and you get f of x equal to x squared plus x plus 1 to the negative 1/3. So this helps identify the inside function and the outside function. The inside part is x squared plus x plus 1, right? So you let u equal to x squared plus x plus 1, and f of u is equal to u to the negative 1/3. Like I say, we still follow the formula, right? Derivative of the outside function multiplied with derivative of the inside functions. So you have df dx is equal to df du times du dx. What is df du in this case? So df du, which is the derivative of the outside functions, is equal to negative 1/3 times u to the negative 1/3 minus 1. And du dx is derivative of the inside functions, which is 2x plus 1. Now you put everything together, you get, this is negative 1/3 times u to the negative 4/3, then times 2x plus 1. But u is equal to x squared plus x plus 1. So the answer should be negative 1/3 times x squared plus x plus 1 to the negative 4/3 times 2x plus 1. All right, I'm going to stop right here. That should be enough for the materials for today. Let me know if you have any questions.